Streaming live via the internet. Welcome to ISP Radio, your weekly source for ISP-related news, events, and interviews with industry experts. If you deliver internet via fiber optic, wireless, coax, or any other way, you're in the right place. Chat live with us weekly via ispradio.com every Wednesday at 11 a.m. Central Time. And now a brief word from our sponsors. Link Technologies, providing ISP consulting, support, and hardware for wireless ISPs. TowerCoverage.com, providing online RF coverage maps. And now your host for ISP Radio, Steve Grabiel and Dennis Burgess.
Welcome to another edition of ISP Radio. I'm your host, Steve Grabiel, broadcasting from Moriarty, New Mexico, and we've got Dennis Burgess producing the show and broadcasting it from St. Louis, Missouri. It's just been hotter than hot out here, 90-plus degree days, but we're fortunate with no humidity. So when that wind blows, you can kind of get cooled off, but still 90 degrees plus is still hot in the sun. I've been out working in the fields, plowing in and drilling pipe in the ground recently, and had a little snafu on our first fiber project. We lost a drill stem in the ground, or not the drill stem, but the beacon housing in the ground, and we had to break out concrete and dig down below a culvert, of all things, to find it. We pulled that out yesterday, bought all the right parts to get us back up and running, and we're back pulling pipe in the ground now. So that was an interesting snafu in the new venture into fiber optics. Like I said, other than that, the wireless out here is running pretty smoothly, thank God, and we're able to focus in on doing something different. So, Dennis, what's been going on in your world?
Well, you know, we've been doing lots and lots of great projects. To be honest with you, probably the past week or two has been taken up by a number of customers with denial of service attacks. We've been getting a lot of those, and a lot of configurations that I have found have been basically not, I'm not going to say not good, but not very performance-oriented. So, in other words, it's fine underneath normal load, but as soon as you get something like a denial of service attack or something like that, CPU hits 100%. And these are all nice boxes, you know, Cloud Core 1072s and such. So they should be able to take that. And that's really probably the biggest thing that we've been working on, or I've been working on. Other than that, obviously, WISPA. We got WISPApalooza coming up in October. The Fiber Weekend, getting ready for that. So there's lots of great things going on in the industry, working with the FCC committee as well. But those are probably the new things. You were sitting there saying you were, plowing, and you lost your unit there. And I always sit there and look at that. Whenever you're doing that, it's you have to have spares and a spare of a spare for everything. Because, you know, it costs you so much money just stopping. You know, your crew stops, everything just stops. And you have to have those spares. So I'm glad you got it back, but I hope it didn't slow down your crew too terribly much.
No, it just took us about a day and a half to break out the concrete with the rock, with the hammer and saw cut and dig under. I mean, probably total hours, about 6 hours for 3 guys, but man, that was painful. But I think we're in better shape. The guys are out there right now drilling in new pipe, and we're turning and burning. We've got a really good method down. We cut like 5 or 6 40-foot roads in a day, so I was really happy with that. Making good progress.
There you go, man.
Yeah.
Well, you want to introduce our wonderful guest today?
Yeah, well, we're excited today to have on the show Tasos with RF Elements. He's the managing partner of North America for them, and he's been on the show before with Titan Wireless, and that's still an ongoing organization that he's still in charge of, but he's chosen to venture in the technology side, which is really cool. And I saw some of their latest antennas and stuff at last year's WISPApalooza, and I was all chomping at the bit to get a hold of them, and I'm really glad that Tasos took the time to come on our show and tell us all about them, because it's something that needs to be heard about, and I'm sure you're all going to see it at WISPApalooza. So with that, Tasos, are you there?
Yep, I'm here. Can you guys hear me okay?
You bet.
Excellent. Thanks for having me on the show. I appreciate it.
Well, like I said, I'm excited to have you on the show because there was some innovative stuff I was looking at last year, and I was just wondering, wow, this looks neat. So why don't you go into what you've been doing and where you guys are going?
Yeah, so I mean, we've been doing a lot as a company. We've been getting, very involved in the industry with, the customer base that's out there, the users. We've been getting involved with, WISPA itself, and trying to help create solutions that help the industry as a whole. We have, again, a really good platform for antennas right now, and a lot of new interesting things that are coming down the pipe. So a lot of really innovative stuff coming. We're really excited to be part of this industry, and I'm really excited to be with RF Elements and be on this side of the industry right now.
So you joined RF Elements to get in the manufacturer side. Tell us about, and you mentioned WISPA. Tell us a little bit about what you were, before the show, you were wanting to mention about WISPA.
Yeah, I mean, so there's quite a few things, right, in getting involved with WISPA and supporting the organization. I mean, I've been in the industry for 12 years. I know that a lot of people have different, ideas of how useful WISPA is, and there's a lot of back and forth. But we feel that WISPA has done a lot for the industry. A really interesting thing that's happening now that I think has been lacking for a long time is there's a group out there called the Carmel Group. I don't know if any of the listeners are familiar with them. They're working with Nathan at Whisper, and creating a market research document about the WISP industry. Since the beginning, and even to this day, people always ask me, well, what do you do? What's a WISP? Explain your industry, right? When you say wireless, they instantly think that you're AT&T or Verizon manufacturer for 3G, 4G cellular type stuff, and it's really hard to really paint a picture and sometimes explain exactly what we are, and from the business standpoint as well, being a WISP or being a manufacturer in the WISP space, or anything to do in this industry, there really is a lot of information that's lacking out there. And for the first time, WISPA has engaged the Carmel Group to go out and create kind of like a white paper and a marketing document to really leverage the WISP industry to give us more of a voice. WISPA does a lot in the realm of FCC and legislation for WISPs and spectrum and stuff like that. And when you go and you try and explain the size and scope of the WISP industry and where we are and how relevant we are as an industry, there's really no supporting documentation. So the Carmel Group is, again, creating a document, creating a white paper, a market research document to, put on paper, how big the industry is, how many subs, to show that, we have vast numbers, what the value of the WISP industry is, who the big players are, who the up and coming players are, and really give the WISP industry, a voice. I know they've been working on this for quite some time now. And I think in October, hopefully at WISPA Palooza, they show their findings and have something that we can use. But this really helps everybody. It helps the small WISPs and the big WISPs when they want to go to a bank and get funding, right? They can show, hey, look at the industry that we cover, and kind of, what the market value is, and that we're actually we are a big group when it comes to wireless. It's not just about the cellular carriers. I know that they're reaching out to and will be reaching out to a lot of WISPs trying to get data. I know they need some help from the WISP industry as far as WISPs telling them their size, their location, how many subs they have, and getting some kind of marketing data to fill this in. So really, we all have to work together to support the Carmel Group and WISPA to get this document to light and out there, so that way we can help grow the industry. That's one of the most recent things that's happening right now. As far as RF Elements as the company in WISPA and the industry, we're trying to create and are creating solutions that are totally different. We're not looking and not trying to kind of create the better mousetrap, right? We don't want to take the type of antennas that are out there now and tweak them and do things to them to try and make them slightly different so somebody buys them. We're revolutionizing and redefining, sector performance and how, radios and wireless networks should work, right? So that's really where our focus is in the innovation of new products and totally different products, not the same thing repackaged a different way with some different firmware, maybe slightly better receive sensitivity, wider channels, and what have you. I mean, we're really looking to do something totally different in all aspects, not just a single point, right?
Yeah. So tell us a little bit, RF Elements, about where they're at. You're the managing partner for North America. Where's the manufacturing located? And it's a global company, correct?
Yeah, it's a global company. So I have a presentation. If we can put the slides up there, we can go through the presentation and talk through some of that stuff. And then I can tell you about, some of the technology that we have, some of the products that have been out for a while, new stuff that we're doing, and kind of our vision for where we think wireless equipment and antennas are going in the future.
Perfect. Take it away.
Okay. Just let me know when the slide's up there.
Yep.
I can't see.
Yep, it's already up there.
Okay, great. So, back one, sorry. Okay, so RF Elements is based in Slovakia in the European Union. RF Elements was established in 2010. Currently, we have over 70 employees, and our focus is basically innovation and innovative products. The majority of our employees are all in product development, right? So the majority of our efforts are in innovating new products and developing new products. We have multiple offices across the globe. I run out of the Austin, Texas office, right? So I'm the managing partner for RF Elements North America, and I take care of all the Americas, including some other areas like the Pacific, Australia, New Zealand, where they speak English, and the UK and Europe, but generally it's the Americas. Our headquarters is in Slovakia, which is in Bratislava, which is the capital of Slovakia. And then we also have a warehouse in Hong Kong and manufacturing. So a lot of our products, the parts are manufactured in Asia, but the majority of the assembly, test, and QA is done in Europe and in Slovakia. So we've gone through a transition where we're doing a lot of the QA and assembly now in Slovakia. So we're managing the quality a lot better. So the first product line that I'd like to talk about is our sector carrier class antennas. This is a traditional type sector. The sector has been on the market for quite some time now. It's been close to 3 years, maybe a little bit more. And they're different than what's out there right now, and we'll kind of go into the benefits of our carrier class antennas. So sector carrier class antennas are designed for cluster deployments, right, where co-location is important, where you want to kind of be able to isolate your co-located antennas. They also provide excellent horizontal and vertical performance. So the horizontal and vertical beam performance is very good on these antennas. It's excellent, and it's also very lightweight aluminum construction. So from the tower climber's perspective, a lighter antenna is a better antenna, right?
Yep.
So one of the first things that you notice about our antennas are the back shields that are built into it. So now the back shield is, again, totally different than the back shields that most people are used to. A lot of people are buying aftermarket shielding kits and putting on the traditional antennas that are out there on the market. Our back shields are more than just a piece of metal, right? They have special frequency selective surfaces, and these surfaces are tuned specifically for this antenna, for this particular frequency range, and they help do a lot to the antenna performance, not just the shielding for back radiation, but it also helps the beam performance. So our carrier class antennas have balanced vertical and horizontal beams. So if you look at the animation on the left, that's our sector carrier class. You can see how the vertical and horizontal beam widths are practically identical. If you look at mainstream sectors on the market, their vertical and horizontal are usually mismatched, right? So when you buy a 90 or 120 degree antenna on the market, typically one of either the vertical or horizontal is usually close to that beam width. or the average of the two, horizontal and vertical together, come out to the 120 or 90 degree that is typically spec'd for antennas on the market, where our symmetrical our sector carrier class antennas have very good horizontal vertical beam performance. We also have optimized beam widths, right? So, we get the question all the time, why do you guys build a 100-degree antenna? Why aren't you doing a 120 or a 90 or a 60 or even a 45? And there's a simple reason for that. We built this antenna for a reason, to be built to the highest quality, not only in construction, but performance. This antenna is a traditional type sector, which is a patch array sector. Very common to a lot of the traditional antennas that are on the market today. The difference is, in a patch array antenna, the beam pattern that comes out has a kind of natural beam width. It has a size that it wants to be naturally, right? And when you build or sell a 120, 90, 60, or 45 degree sector, you have to do stuff with shielding and reflectors to squish that beam pattern and make it 90 or 60. So at that point, it's kind of unnatural, and that's where you get these huge side lobes and you get these unbalanced beams. So we decided to, let's break the trend in the market. Why do I have to develop an antenna that's this cookie cutter fraction of 360, multiple of 90 type architecture geometry, right? We wanted to build an antenna that had a well-performing beam, whatever that may be. And 100 degrees seems to be it. It's at the -6, it's 75 at -3. And those frequency selective ribs that are on there help form the beam to make sure that the vertical and horizontal overlap. So we built it this way because that's the best way to give you the best performing antenna without looking at trying to follow everybody else with these kind of standard geometries in the market. So here's a competing antenna that's on the market, right? So if we look at the vertical and horizontal beam pattern of the competing antenna on the left, this is a 45-degree AC sector that's on the market. You can see the RF simulation. You can see in horizontal, yes, the beam looks like it's 45 degrees, right? But what you also see is you see these huge side lobes. I don't know if you can see my pointer on the screen, but you can see these huge side lobes coming off the right side, off the left, and you also see this leakage coming out the back of the antenna. Now, this may look like it's close to 45, but it's not even straight. It's not even coming out straight from the azimuth, the zero azimuth of the antenna. It's slightly cocked to the left. If you look at the vertical beam pattern, you can see this is way more uniform, but it's nowhere near 45 degrees, right? And you still see in the vertical, there's a lot more leakage out of the back of the antenna. If you look at our carrier class antennas, you can see that the vertical and horizontal beams, again, they're not perfectly identical, but they're much better matched. So this is huge in MIMO performance, and you guys know this. You guys operate WISPs or have operated WISPs in the past. You know that when you have a client install, as you start moving to the edge of that sector coverage area, you start getting huge mismatches in chain performance. Chain 0 to chain 1 receive signal is totally different, and this totally messes up the modulation rates of your radios and really brings down the overall performance of your antenna. So with our sector carrier class antennas, if you're in that main beam, in that main 100 degree angle, you're going to get good chain-to-chain performance, right? We also have smaller side lobes, so it's a lot more difficult to connect customers outside of that 100 degree. But our carrier class sectors do have side lobes like traditional antennas, but they're way more balanced, way more suppressed than traditional antennas on the market. The other thing that we get when we don't try and manipulate the natural beam angle of an antenna is we get very good vertical to horizontal gain performance. This is the other thing. There's a lot of antennas out there that have these really high gain numbers, and that gain is usually at a specific frequency, and even in MIMO antennas at a specific polarity, right? So you can see the horizontal here, the red lines in both horizontal and vertical are our 17 dB sector. So you can see across the spectrum that you're getting pretty well matched gain in both the vertical and horizontal. And then the black lines here, the vertical and horizontal for our 20 dB 5 gig sector. Again, you can see that the chain-to-chain performance of both those antennas in vertical and horizontal are pretty close matching. So not only do you have gain that's uniform within the spectrum, also within the angle of that antenna, you have good performance. So a key portion there. The other benefit is the back shielding. Again, our back shield has been tuned specifically for this antenna, and it's made to do more than just, you know, balance the beams, but it's the shielding. So if we look on the left, again, this is a totally unshielded competing 5 gig 19 dB 120 degree sector. You can clearly see that this thing is practically almost an omni, right? But you can clearly see huge side lobes here on the left and right. It's probably 180 degrees in this one polarity, and you can see huge leakage out the back. Here's the same antenna with an aftermarket armor kit on it, right? Again, you can see they've made a bigger improvement on the leakage to the back, so you can see that it's not leaking signal out the back as much as without shielding. But the biggest problem we see here is we start seeing here on the left and right creating even new side lobes, and also changing the angle of the front of the antenna. So it also changes how the signal comes out of the front of the antenna, right? You know, and these shielding kits need to be mounted the same way every time, right? So if it's, you know, if it's damage in shipping and you have some warpage or a corner that's kind of pressed in or something, that totally changes the RF performance of that sector. On the right, with our sector carrier class, again, you can see that the back radiation is really good, and the main beam pattern is, you know, pretty much undisturbed, right? So huge benefit there. The other thing is pricing, right? So our 17 dB 5 gigahertz sector carrier class is only $130 MSRP, right? That's about the same, or actually lower, than the competing antenna without shielding. And then when you add shielding, you're talking at $200 plus. So really, for a lower price, you get a better performing antenna, more balanced antenna, better side lobe suppression, better, you know, back radiation suppression. In a lighter form factor, the wind loading goes down on our antenna versus another competing antenna with armor kits on there. So really, in all aspects, it scores very high in value and performance. Again, the antenna is very robust and durable. So even at that really good market price, you're getting a very high quality constructed antenna, right? So there's a lot of manufacturers in Asia that are pumping a bunch of antennas out that are cheaply manufactured using low quality parts. We use very good UV resistant ABS plastics, extruded aluminum, you know, stamped aluminum, again, stainless steel hardware. So we use very high quality parts in all our construction of all of our antennas. And we know that they survive really well. Here is a picture from one of our customers that installed one of these carrier class antennas on the beach, right? So it was, I think, in Albania. It was out in the field for over 8 months in the sun and in the salt water. And if you look at the picture on the left, you can barely see which one is the used antenna. I believe the one on the left is the one that came from the field, and the one on the right is actually a brand new one. But you can see there's no oxidation, there's no rust. Again, there's a lot of antennas out there that say they use aluminum, and they use a different material. They have some sprayed on, you know, galvanized spray or some coating and stuff that just never lasts. Our antennas do. The picture on the right, you can see the back of the antenna. I mean, there's just basically some dirt from the sand and soot, right? So you can see even the screws have survived. They're not rusting. Everything is high quality. 8 months at the beach would have destroyed and destroys most antennas, you know, on the market today. So our carrier class antennas are compatible with a lot of different platforms. So it's compatible with our Station Box S carrier class, which is a die-cast enclosure that you can put pretty much any Microtech router board inside that's of the same form factor as like a 911, 411, or 711, the small square form factor. So you can put a 411 with a mini PCI radio. You can put a 911, 912, 922, you name it. If it's that small square form factor, it fits in there. We also it's compatible with our Rock Shields, which is our aftermarket shielding kit for the Rocket M series, so Rocket M2, Rocket M5, I believe the 365, and even the 900 Rocket fits in there as well. So it's an aftermarket shielding kit that still allows you to clip on the back, and the cover covers the pigtails. As far as other connectorized radios on the market, the Ubiquiti Rocket AC Lite, the Rocket M series, Rocket Titanium, they all clip on the back and the shield covers it. We also support the router board, the base box, net box, and net metal with the use of an Easy Bracket 912, which is a little plastic bracket. You screw on the back of it, and then it clips and slips right onto the antenna, as well as the Cambian EPMP 1000 line. Again, the EPMP 1000 requires an Easy Bracket, which is, again, is little low-cost plastic bracket you clip on the back and allows you to mount it to our sector carrier class antennas. And the antennas are available in many different models. We have a 14 dB 2.4 gigahertz version. In 5 gig, we have a 17 dB and a 20 dB. And we even have two 3x3 5 gig 16 dB antennas that work with net metals and 3x3. So there aren't many radios out there that are 3x3, but the net metal is one of those radio systems that would work with our 3x3 antenna. And again, they're all price competitive on the market. So I know, no manufacturer comes on a show and, says their products don't work, right? Buy our stuff even though it's crap, right? So our antennas do. So I want to share kind of some feedback from some of the customers in the field. This was Scott Stace with Bluespan Wireless out in Arizona. He did a beta test site with our sector carrier class, and I just wanted to share some of the information. So he did a brand new build out of a brand new site. The initial test site used 4 of our 5 gigahertz 17 dB carrier class antennas with the Microtech Net Metal 5s. What they were looking for was basically better RF performance than they were seeing. They wanted an improved ease of installation and shortened deployment time. So they were looking for a lot of the physical characteristics that our antenna has. By not having to add aftermarket shielding kits, they can reduce the time because it's built in, right? Obviously, it's quicker to deploy, quicker to get up there, lighter to use. So the results is he built out this site, and you see it there in the picture. So when he compared the signal strength and CCQs of the CPEs from this site to other sites, he noticed a better overall signal strength and CCQ number. So it's one of his best performing sites. He also noticed that the dead zones were significantly reduced compared to Ubiquiti sectors with shielding kits that he was using. So probably has something to do with the kind of the way the side lobes were allowing his customers to connect to, and he was not connecting in main beam performance. Also, he had no worries about the edge of sector performance. Again, as you get closer to the edge, he was still getting good chain-to-chain performance, right? And he had a faster install and killer price performance. So moving on from this site, he started deploying these sectors and only these sectors on his new sites and retrofitting old ones as sites went bad with our antennas. Again, here's another feedback from Chadwick's with AU Wireless. I believe he's in Colorado. He used our antennas with Cambian EPMP radios, and his signal strength improved about 10 dB in SNR, right? So he was going from neg 65 to neg 55, and speeds were increased over 25 meg. So he was doing much better. His radios perform much better with our antennas than the Cambian antennas, which look extremely similar but perform totally different than our antennas. Again, another customer, this is the customer in Albania that we saw the pre and post pictures at the beach. Again, so he says the advantages were very high in regards to quality and stability of the connection. Behaves much better in a frequency crowded environment. So he's obviously getting very good use of our antennas, and the performance he's seeing a definite increase. So that's our carrier class line of traditional sectors. I know you guys get questions. If you have any questions, maybe we can address them now, or I can continue going into our symmetrical horn antennas or symmetrical sectors.
So
any questions, Dennis?
Yeah, let's take a look here. It looks like one person asked, I'm just going to read this verbatim. Are
Yeah.
your antenna ratings using 3 dB or 6 dB?
Yeah, exactly. So we post both, right? Just look at our spec sheet. So the only reason we show -6 is because another manufacturer kind of created the new standard of -6. So everybody's showing -6 in the field. So you can see both -6 and -3, and I believe it was in the slide I had previous. Our spec sheets show both -6 and -3. So
Can you
show them both.
explain everybody what that actually means on the antennas?
Yeah, so if I wish I had something to show, but basically there's, as the antenna irradiates out, there's angles in which the antenna comes in. So you have drop-offs of gain at -3 dB, -6, -9, right? So and it goes down the angle of the antenna and how it radiates. So at -6 dB edge, we're 100 degrees wide. And at -3, we're 75 degrees wide. So you can effectively use this antenna as a 75-degree sector if you wanted, if you base all your calculations and stuff off of the -3 dB spec.
Gotcha. So just for, I think maybe another way, a lot of people look at their antennas and you go, oh, it's 120 degrees, and then they say -6. What they're actually saying is, at the edge, if you go between the two, if you go from the middle point, that's -0. So that's the peak gain of the antenna. If you
Correct.
go all the way out to either side of that 120-degree beam width, that's where your -6 is. And that's what they're trying to specifically say, is that this is not a 120-degree sector. This is a 100-degree sector at -6.
Correct.
Basically. So it just gives you a different thought process to calculate, etc., on how you're going to plan your deployments.
Yep.
Gotcha. Just making sure that everybody knows how that works, so they can actually compare. Comparing apples to apples is sometimes really hard when the
It is.
apples aren't the same.
Yeah.
So
Yeah, definitely.
awesome.
Thanks, Dennis. Any other questions?
That's all I have.
Now, that was based on your old school stuff that you've been selling the heck out of. I've used quite a few of them, and I'm extremely pleased with them.
Yeah, so I mean that's kind of, we're moving forward in technology and putting out, like I said, totally different antennas. So that was kind of the attempt to do the best that we can do with a traditional type sector antenna, right? So shielding built in, balanced beams, unified gain and performance construction. So moving forward, we go to our symmetrical sectors, or the horn antennas that people have seen, and this is really where the game-changing stuff starts. Although I think what we've done with traditional sectors is pretty impressive as well. So,
Absolutely.
is the presentation back up?
Yes, sir.
Okay, great. So these are our symmetrical horn antennas. So a lot of people may have seen these at shows before. So we'll start talking about what makes them unique. So the first question we always get is, well, what's a symmetrical sector? And it's pretty simple. We talked about the beam angles of traditional antennas, right? So our sector is 100 degrees wide in azimuth, and traditional sectors on the market are 120, 90, what have you. But they typically have a really small horizontal beam, right? So they're usually about anywhere from 6 to 8 or 9 degrees tall, right? So this is a pretty flat pattern, as you can see on the left. So you can see this is really wide, but it's really narrow. A symmetrical sector is just that. It's symmetrical, right? So if you have a 30-degree wide symmetrical sector, it's also 30 degrees tall, and there's there's a lot of benefits to that, and we'll talk about them. So the main thing is it's unique beam. So you can see the azimuth cut is identical to the elevation cut. So again, this is our 30-degree antenna. So you can see it's 30 degrees wide as well as 30 degrees tall. The other thing is there's no side lobes. This is the hugest thing, and we'll talk about that a little bit later. So not only is it symmetrical, it has no side lobes. So if you connect a customer to an AP using one of these horn antennas, you know that you're always in main beam connectivity. And I can't stress how important that is. There's a lot of customers out there connecting on side lobes. We got a lot of early feedback from these antennas, and a lot of people complained because when they went outside of the 30, 50, 70, whatever it is, beam angle, the signal dropped off, and they were mad because there was no side lobe. I'm like, that's the idea. We need to get you side lobes. The best side lobe is no side lobe, right? And
another.
Yeah, our unique beam patterns are identical. We went through and did beta sites, and I can't tell you how many customers we found connected to the back of a sector, right? Because that was stronger than the side of the one that they're supposed to be connecting to. I mean, it's really eye-opening as to what's happening, and these horn antennas, symmetrical horn antennas, are just phenomenal, and they do exactly what we say. Again, a lot of people's complaining, but they definitely do what we say it's going to do. So if we look at the beam pattern comparison here, again, there's a bunch of things that happen, right? So traditional sector on the left, you can see it has huge side lobes. You can see in the top and the bottom, right? Something that happens in a traditional sector is as you change frequency, the beam pattern changes. So you can see as we go higher in frequency, it now goes from 120 down to 100 degree, right? So it's only 120 degrees at the lower frequency, or it could be vice versa, right? It's just the main concept here is as you change channels, your beam pattern changes. So you deploy a sector, right? You deploy a tower, you get a customer signed up, everything is great, he's towards the edge or whatever it is, but everything's performing well. All of a sudden you have noise, right? What do? You change channels. Boom, all of a sudden you're like, how come this customer that was close to the tower now has crappy signals? Because the side lobe shrunk and now he's not getting the signal intensity. He's on a side lobe, or he's on the edge of the sector performance, which has now become narrower. Our beam performance and symmetrical horn antennas, as we change frequency, you can see that the main beam here doesn't really change shape much. So again, not only can you guarantee that's the same case even when you change frequencies, right? So changing channels doesn't affect the performance of your overall AP, right? Another benefit is coverage without null zone or dead zone, right? So we know, again, traditional sectors are notorious for this, right? You're covering a big area. They work great in flat areas, but if you're really high up in a tower, you get a huge dead zone underneath. Again, you're connecting into a side lobe of the antenna, but we can show the kind of relationship ratio between a symmetrical sector and a traditional sector. So our symmetrical horn antennas still have a null or dead zone, but it's very small in comparison. And in most cases, you need zero down tilt at all in order to cover a whole area. So this is another unique benefit of a symmetrical horn antenna. Again, frequency constant beam and a very stable beam pattern. As you change channels, you can see here that the beam pattern doesn't change much at all. So it's very uniform. Another benefit to the antennas. Balance gain. This is probably, again, another huge thing. Not only do you guarantee if you're in main beam connectivity that you get the same performance, if you change channels as well, the gain doesn't change as much at all. If we look at the horizontal and vertical, it's pretty much identical. If you overlap them, they literally are right on top of each other. So you will not see better chain-to-chain performance on any other sector on the market than one of our symmetrical horn antennas within the coverage area. You may see it on a competing sector on the market, a traditional sector, if you're within 20 or 30 degrees of that azimuth, but it really starts to drop off as you get to the edges of that 120 or 90 degrees that they spec it at. So really good gain performance in both polarities. And this is the gain performance for our 30-degree sector. Again, no side lobes. You saw this earlier with our carrier class antennas, how we suppress side lobes a little bit, but you can see with our horn antennas there are zero side lobes. So you can see compared to a traditional sector, again, very clean, 30 degrees, no side lobes, and practically zero. I mean, there is some leakage out the back, right? But the magnitude of that signal is so small that your radios can't. So it's invisible to your radios, right? It's so small it's hard to even measure it. You would see probably something coming out the back, but it's undiscriminating from your radio. It's hard for it to even see it. Here again is another comparison to that 45-degree sector. Again, we compare this one because it's closer to the 30 degrees. So again, you can see ours is straight out, uniform gain throughout the main beam, no side lobes, no back radiation. The horn antennas are truly the wave of the future, and for more reasons than just its unique beam and standard performance, but it's a tool that enables you to do so much more, and we'll get into that a little bit here. So the scalability of these antennas is phenomenal, right? So you're not stuck again with the standard geometries that the people have been building towers with forever, right? 490s, 120s, or something to that effect. So you can actually now send signal to where you need it and not go beyond that area, because you have to remember, once the signal passes your coverage area and it becomes unusable for you, it instantly becomes noise for other antennas, and it doesn't stop, it keeps going. So really we're trying to change the mindset of WISPs, right? And it's difficult because we've been pushing more and more gain forever. So when they see these low gain numbers, or what they perceive as low gain, it's an instant turnoff. And if you use the antennas right, in the right way, then it's not, right? So, you may need to cover a 90-degree area, right, in a larger distance than the single 90-degree antenna offers, right? So you can use 330s because you can co-locate them to make a 90-degree coverage area. So basically you can build, mix and match, and use these antennas to build the coverage you need. It's not about a single antenna or a single skew. It's using these antennas I'm at a loss for a word here, using these antennas together as a complete system to really design the coverage you need. You need more distance, you could use the tighter beam angles clustered together to give you the distances that you need. If you have a bunch of your customers are close into the tower, right? Why send the signal 10 miles out when you can only propagate it, 3 or 4, right, or less? So really, it's difficult to do this with traditional antennas, and our symmetrical horn antennas give you very unique scalability to be able to design the networks and only send signal where you need them.
Can you go back a slide real quick on that design? I would like to really point out something to a lot of people, because a lot of people, I see this happening all the time, and there's direct issues with it. So what we get is a tower site, especially I'm going to use the one either in the middle or on the right here. In this tower site, the big bulk of their coverage, or they have a lot of users, let's say due north of the middle one. And what we find is we get people that'll put 2 or 3, and I know a person that has 4 90-degree sectors facing due north. And while it works like crap. Simple as that. This right here is proper RF design. You do not want your antennas, the beam width, or at least the core beam width of them, to overlap very much at all. Just like this, where you see that the 50 and the 30, they do overlap slightly. That's fine. But you don't want 4 90s facing the same direction. That's really,
I'm guilty.
Yeah, really bad RF design. As a matter of fact, if you get into other products such as LTE, that is a big, ugly, fat no-no, and it will cause your LTE radio to hop base stations all over the place.
Right.
So it's actually something that the cellular industry, as well as LTE, does. You can't even do that. That is not something that they would even ever consider. What you would do is you take, let's say you had a 60 degree, well, you take the 60, now you put 2 30s up, and you move the customers that would be on the 130 to the 130, and the other customers to the other, and nice and easy. It does take a little work, but that is the proper way of doing it. And I'm just making sure I point out that this, if you have options from 90 to 30 to 60 to 30, etc., you have easy ways to upscale your network very quickly and effectively with proper RF design.
And economically.
Yes.
Yeah. and that's the big thing when we start talking about the size and how compact it is. I mean, it's, you can put up, putting up 4 90s, again, poses lots of issues from the RF standpoint, from wind loading standpoint. But having 3 antennas, right, will give you the same capacity with less loading, right, and better RF performance because it's only looking at 30 degrees of that 90. So, I mean, it overall is definitely the way to go. And I can show you, we have a use case that shows exactly that, where a customer did that. And there's a lot of, I can sit here and talk for hours and hours and hours about case after case and how well these have worked. And, they're not perfect for everybody. We're not saying that, you should build out every tower based on horn antennas. I mean, you can, and more power to you if you want to, right? But, use these in combination with traditional sectors as well. I mean, our sector carrier class antennas with these antennas working together are phenomenal, right? So again, it's just another tool. It gives you the ability, and the goal is to, again, try and break that mindset on how we've been doing things, because it's obviously not working. We've completely trashed the 5 gig spectrum. It's going to get trashed even more with these cellular carriers offloading on 5G. I mean, really, this is the way to go, and this is the time to do it, is now, to protect yourself and protect your investment. I mean, really, it's not marketing fluff. I'm telling you, it's going to happen, and you're going to see it. You're going to see other mainstream vendors now soon making horn antennas probably. I'm pretty sure the market is going to follow our lead. So anyway, we can move on.
I have a quick question. So
yeah.
This is access side only. Is there any special antenna that RF Elements makes for the client side, or can we just use anything that that we're currently using, like be it an M5 or a SXT or what have you?
Yeah, so I mean, at the moment, the answer is yes, but probably no to most people, right? So we'll just go with the no. Right now, we don't make a specific client side antenna. We do have our Ultra Dish product, which is phenomenal, right? So it's a $99 24 dB 5 gigahertz parabolic dish, and it's TWISTPORT enabled, right? So if you want to use a rocket with an Ultra Dish as your CPE, absolutely, it works. If you want to use an Ultra Dish with a EPMP 1000 radio to maybe replace a Force, a Force 110 and a Force 200 type CPE, absolutely. But there isn't a client-side antenna at the moment for kind of the lower cost SXT or sextant market that is based on this technology, right? We do have a whole integration platform. So we have our Station Box XLs, we have our Station Box XL carrier class, which are very high quality antenna enclosures that you can put router boards inside and make CPEs for sextants replacements. We have the Station Box Micro. We have quite a few antenna enclosures basically made for Microtech router boards for the CPE side. So that's something that you can definitely look at the moment.
Okay.
Yeah. Okay, so let's go here to, is the slide still up?
Yes, sir.
Okay, cool. So let's talk about compact size, right? So again, you can see these things are lightweight and small. So you can mount 3 to 4, depending on the beam width antenna, on a single mast, right, where you would put a traditional sector, right? So again, in the space of a single traditional sector, you can have 3 times the customer load, right? I mean, we get people all the time, well, how many customers can I put on an AP, right? Well, it's not really related to the antenna, it's more related to the radio platform. So we know the average is very very wide, right? Anywhere from 20 to maybe 50 customers, depending on the bandwidth packages that you're delivering and connection rates. Depends how you run your sector. If you're running huge point to multi-points, then you have customers that are marginal signal and customers that have good signal. So it's a very, very diverse way of answering it. But again, you have a single antenna with a single radio when you're using traditional. So we can take a 90 degree, turn it into 330s, and you get 3 times the customer density in the same mounting location as a single one. It's plain and simple. Wind loading for 3 of these antennas is way less than 3 sectors, and probably a little less than a single sector as well. So again, robust and durable. Everything about our products, the price is very competitive, we feel, to other products on the market, and they're made of high quality parts. Anybody who's seen these can attest to that. Anybody who hasn't seen it, I assure you, you're not going to buy one of these things and say, man, this thing is poorly or cheaply made. We thought about a lot of things. It took us about 2.5 years, 2 years to develop these symmetrical horn antennas. And it's not because we wanted to just create a unique antenna from the RF standpoint, but we wanted to look at it from the bottom up. We wanted to start from the ground and work to the sky, right? So it's built well. It has the best RF performance. We looked at the user experience of the installer, right? It's lightweight, so it can be carried up. Most of these things can be installed with one hand, right? All our symmetrical horn antennas have our patent-pending twist lock ports on there, right? So radios can be installed really easy, makes maintenance easy. I mean, just everything about this antenna is easy. It should ease your mind. This is the type of thing where you install a radio on this antenna and you just forget about it. I mean, most of the customers that are out there using these antennas are forgetting that they had customers on their network because they just don't get the phone calls. And I mean, again, I'm not trying to overmarket this and say that it's perfectly perfect in every scenario. Obviously, there have been some potential misunderstandings about how these antennas work. Part of that was our fault kind of in the earlier days, but for the most part, you install these antennas, they work just as good or better. We're seeing better performance in AC than N because AC is more susceptible to noise, and these things do a great job at reducing noise. So overall, we try to look at every aspect of this antenna, not just its RF performance, but even its user experience and maintenance. So very, very well built.
Will it fit into a backpack?
Yeah, it will fit into a backpack. Absolutely, right. And it's really easy to clip onto a carabine on your side, 3 of them, and climb up the tower. And it's just overall it's a great experience. We believe, and we know from customers, they love it. So again, another unique part of our symmetrical horn antennas again is the TWISTPORT ecosystem, right? This is the huge thing. We realize that there are a lot of small form factor connectorized radios on the market from Ubiquiti, Cambian, and Microtech. So we created these TWISTPORT adapters that allow you to use these radios with our antennas, to bring these radios into our TWISTPORT ecosystem now and into the future. So basically, the adapter makes a current connectorized radio compatible with our TWISTPORT antennas, and it's quite easy. You just take it, you slide it in, it clicks in place, and then you twist it on the antenna, and it's done. I mean, it's really simple. Now, what this done is a few things. We've actually can increase the performance of radios, not only with the noise canceling ability, let's say, the noise filtering of a horn antenna, but these TWISTPORT adapters actually help. If you look at a traditional radio setup, you usually have some pigtail apparatus that connects your radio and interfaces it into the antenna. And we have kind of low quality pigtails, some with right angle connectors on there. So we have a few things. Not only can you expect to see from 1 to maybe 3 dB of loss just because of that connection interface, it's also the #1 failure mode for most outdoor wireless networks is water ingress. You guys know that. With our TWISTPORT adapters, with these aftermarket or these other vendors' radios, you've reduced loss. So you can see anywhere from maybe half a dB. I don't want to say max, but I mean no more than 1. Definitely 1 dB or less. There are pigtails inside there, but they're semi-rigid. They're extremely high quality. They're tuned. They're not being twisted in a circle, to get it tucked up under the shield. I mean, really, everything these TWISTPORT adapters, the way they've been designed, helps increase performance even. So you'll get more in your link budget because there's less signal loss through the pigtail apparatus. You'll get less failures because of water ingress. You don't have to tape. You don't have to have any tools, no wrenches. I mean, really, it makes it work really, really easy. Again, we talk about cross-platform compatibility, right? So currently we have TWISTPORT adapters for many, many radio systems out there. Ubiquiti Rocket radios, so we cover the PTP and PTMP Rocket ACs, the Rocket 5 AC Lite, the Rocket 5M. Again, the whole gamut of Ubiquiti 5 gig radios. Cambian EPMP 1000 series, both the connectorized regular EPMP 1000. I think there's a light AP, the synced AP. They all work. One TWISTPORT adapter works for both of those. And then for Microtech router boards, right? So again, on the right-hand side, we see these two adapters allow you to easily take a router board 911, 411, 711 type, or 74 or 9 series board inside here, and makes it now TWISTPORT compatible with our TWISTPORT ecosystem, whether it's the horn antennas or our parabolic Ultra Dish 380 series. So again, for point-to-point and point-to-multipoint, and maybe we can say high-end CPEs, depending on how you value price of the device as far as quality goes. Definitely high-end CPEs you're capable of, right? Another thing, something people have been asking about a lot, right? So the Rocket 5 AC Prism with GPS, right? So this has been released by the company, right? It's been put out on social media and stuff. This is the TWISTPORT adapter. This is what the Rocket 5 AC Prism TWISTPORT adapter looks like. It should start shipping next week. For the U.S. specifically, we're air freighting them in. So distributors should have them in the next week or two. So we now support the Rocket 5 AC Prism in a TWISTPORT type device. So again, if you want to use it for point-to-point or point-to-multipoint with our horn antennas or Ultra Dish, again, it's compatible. That's the whole idea behind the TWISTPORT ecosystem, is making these radios compatible with all the antennas that we come out with in the future as well.
Quick question on the TWISTPORT.
Yep.
So in this picture, I would stick my Rocket 5 AC and just it goes up there. I mean, do I have to screw anything, or is it just made up to the?
Actually, let me. You guys see this here? Let's see. No. Here it is. All right. So let me do this one here real quick and show you the animation of how it works. So ready? Can you see it up on the screen?
Yep.
So pretty much it goes in on an angle, and you can see the GPS antenna on the bottom, and just clicks in place. That's it. Pretty easy. Press the button, and the radio comes out. That easy. So again, toolless. Just like all our other TWISTPORT adapters, you just lay it in there and it connects on.
So the threads on the radio they're not even a part of the connection to the TWISTPORT.
Correct. So the threaded SMAs go into the SMA receiving ports in the adapter inside there. The center one's for GPS, and then you have your two outside ones. So again, it's just like all the other TWISTPORT adapters that are out there on the market right now.
Real easy, cool.
Yeah, real easy. Again, toolless and pretty simple, right? So this is going to be the next game-changing thing when you introduce GPS synchronization, right? We have people lining up to do 12, 30-degree sectors with GPS sync. So it's going to be pretty interesting. We can't wait for this to get on the market, and you should see some pretty cool stuff.
Cool.
All right. So the last part again for cross-platform compatibility is the newest symmetrical horn carrier class antennas. So this is basically the symmetrical horn antennas we showed about without the TWISTPORT on them. So now we have a SKU that has end connectors on there. So again, these allow you to connect a different class of radio, right? These are great for like Mimosa B5Cs with the point-to-multipoint firmware. We're envisioning the A5C 4x4, right? So two of these in conjunction, one on top of the other, to give you a 4x4. Again, PMP 450, Cisco radios, net metals and net boxes. Those are slightly too heavy and too large to make a TWISTPORT adapter for. So now we have an antenna line that gives you connectors to allow you to also interface those larger form factor radios that aren't suited for a TWISTPORT type adapter, right, into the ecosystem, so to speak.
So we did.
Okay, so sorry?
Yeah, we did have a question since you kind of mentioned it here. One of the questions that were online is, are you guys going to plan or going to develop any 4x4 or 8x8 beamforming antennas specifically for products like the Mimosa A5C?
Yeah. So I mean, I can't share the total roadmap, but man, we have a lot of new and exciting products coming down the pipe, right? So we're going to have some pretty good announcements at WISPAPalooza this year in Vegas for some new products that are coming out. But yeah, I mean, we're looking at everything from higher density MIMO antennas 4x4 and beyond, let's say, We're also looking at different frequency ranges, right? We know the LTE market is growing, so 2.5, 3.5, 3.6, that whole regime of frequencies are definitely something that we're looking at. It's on the roadmap, and just stay tuned, and we should have some stuff. Yeah,
I think the short answer is yes.
Yeah. The short answer is yes, right? We're again, RF Elements is we're really conscious about our customers. We really want to provide good service and good product, and again, be different in every way to the customer base out there, right? We're trying to go beyond not only in the products, but how we deliver products, how we announce products. Again, we know there's a huge history of, hey, look at this new product that's coming out next month, and 12 months later it's still not ready, right? So we're trying to break that mold as well, right? So
thank you.
Yeah. So again, look, the manufacturing process, and I'm really not bashing on any of the other manufacturers, because manufacturing products is tough, man. You have a design that's great, and you go through manufacturing, something doesn't happen right, so you have to tweak molds, you have to redesign, you have to retune, and go through it again. So having zero delays is never going to happen. But I believe in the industry, as a manufacturer, we can greatly reduce that by not opening our mouths too early, by not promising delivery of product way ahead of what's physically capable, because we want to just create a buzz, right? So again, I'm trying not to talk about too much in the future. I'll just only say we have a lot of stuff coming down the pipe, so stay tuned, and we'll definitely have some stuff to address a lot of the things that we're getting questions about as far as antenna technology goes.
Excellent. Let's see if we can wrap her up.
Yeah, let's see here. So I can run through this here again. Some differences between symmetrical and traditional antennas. Again, symmetrical sector is a more narrow, dense sector. It's for moderate distances, great in hills and mountains, right? Where close-in customers are, where you have space limitations and wind load issues, compared to a traditional sector, which is more of a wide, long distance, flat countryside ideal antenna.
Can you give or reiterate on? Never mind. You're on it. Know exactly where I'm going. Okay.
Yeah. So again, another thing about the dead zone and down tilt, right? So you can see the darker gray color is a traditional narrower vertical beam, right, of an antenna. So you can see in this type of topology here, you have to deploy great down tilt to try and get customers. This customer here would probably be on a side lobe, or you're going to install multiple traditional sectors, one to catch the high guys and one with major down tilt to get the low guys. You can see with our horn antennas, that's not really necessary. You can employ down tilt, and very little is needed, if anything. This is obviously an extreme, so you can see this one guy isn't covered. We have to go to about 6 or 7 degrees of down tilt to maybe get this guy, but even with 12 degrees of down tilt of a traditional sector, you still don't get everybody. So it clearly shows the benefit of these antennas and their coverage beam.
What's moderate distance?
I'm getting there. Next slide. So moderate distance, right? Got it.
Oh, beautiful. You're awesome.
Yeah, so this is, again, the question we always get, right? These are, and we're finding that these antennas actually go further and further, right? But it really depends on what you use as a client. We always get that antenna. What's the distance of this antenna? Hard to say. What radio are you using, and what kind of CPEs, and what's the noise environment like, right? So if we were to kind of classify these antennas based on range, if we're looking at an average 21 dB gain CPE, right, so that'd be like a nano bridge 21 or a power beam 300 or something, is roughly in that 21 dB. A 90-degree sector can get you roughly about 2.5 to 3 miles, right? Our 30-degree symmetrical antenna with 18 dB of gain, roughly 6.6. Man, we have customers using 30 dB dish antennas with rockets from Ubiquiti doing 15 to 16 miles on, a 30 or even a 60-degree antenna, right? So our 60 is spec'd at 3.5 miles, and we have a customer doing over 14 miles, again, with a 30 dB dish antenna and rocket, right? So obviously you have power on the side of that to make up the link budget. So again, you can see a traditional sector obviously goes a lot further based on the same CPE, because it's focusing more of its gain forward and it's squashed. So again, if we go to the smaller microcell, these antennas are definitely the way to go. Okay, quick case study. This is from Rick Hughes at SOS Communications. He did one of the first deployments with horn antennas here in Texas. And so he had his primary hub. It was on a water tower. He had 85 clients, 185 clients on 4 ubiquity sectors. They were 19 dB, 120 degree. And he basically replaced one of these. Actually, this is a 90 degree. Sorry, he had 4 90 degree. This is a typo. I apologize. So he replaced or tried to replace a single 90 with 3 symmetrical horn antennas. If you look at his layout, you can see there's way more clients on here than we have mapped. But you can see it's pretty dense. It's in this sector right here, this 90 degree swath where he put 3 90s up. So he had the same frequency issues everybody has, sharing space with competing WISPs. He had very low performance because he had only 4 APs with 185 customers. So he had no room to expand his customer base or upsell service. We know upselling service is a huge thing in this industry. You want to give them more and more bandwidth and charge them more and more money, right? So you can't do that with limited capacity. So what he did was he added 3 30-degree sectors covering a 90-degree area. He was able to add another 100 customers to this site with no interference issues. These 3 were actually overlapping with the 190-degree sector that's here. So he was actually able to keep his regular 90-degree sector covering the low-cost customers that he has that he's not giving high data packages to, and migrate customers that he had on that 90 onto these sectors, and also upgrade service. So he was able to add new customers and upgrade customers that wanted to be upgraded by offloading them to these antennas. So again, it's another way of looking at your business and upselling packages and adding customers in a really small small form factor. Again, this is a huge water tower, right? So loading issues wasn't an issue, but as Dennis mentioned, having 4 traditional sectors, either side by side or one or the other, trying to cover that same 90-degree area is not the best way to go, right? So by cutting that up into 3 30-degree areas, he was able to do it in overlap with a single traditional sector. So really great. Here's some feedback or some signal strengths. You can see one customer here at 2.5 miles on the old sector was seeing a neg 74. After switching him over to the 30-degree sector, he was getting a neg 61, so it's about 13 dB of an improvement. The big thing we're seeing is not always the signal strength or the kind of capacity, but it's the quality of the signal. This is huge, right? So you can see AirMax quality and capacity jumped up big time. Yeah. This customer here is at 5.5 miles. He went from a neg 77 to a neg 69. And again, you can see a huge improvement in AirMax quality and capacity, right? So the other thing is he had to run a 40 megahertz channel originally in order to deliver more bandwidth. He's able to deliver more bandwidth with a 20 megahertz channel now and get better signal because he has better noise isolation than a 40. So he saved spectrum. He saved 2 channels here basically by going to 20 megahertz channels on all his radios as well. So overall, again, it helps everything from spectrum efficiency to signal quality and so on. So again, real quick, just a few other little items here, right? So here's another customer, AU Wireless. This customer also tried our horn antennas. He was on a 3,000-foot mountain side. You can see down here in the valley, he was having a hard time with traditional sector and down tilt. He was able to put 1 horn up and significantly better performance with no side lobes, good SNR, and good vertical performance. So he could get all his customers and main beam connectivity with very little down tilt, and he didn't have to sacrifice some customers. Again, another customer had a problem with clients close into the tower. This one was only 140 feet in the air, but at 140 feet you have a pretty good dead zone underneath a traditional sector, and you're going to be on a side lobe. So with the horn antenna, he didn't have that problem at all. And here, this is a great one. This is from a customer in Alaska. This shows you the co-location ability of these horn antennas. I mean, he was able to mount 7. These are the AC PTMP radios from Ubiquiti, right? No GPS, but he's able to co-locate 7 of these 30-degree horn antennas on that small portion of that tower. If he had to put 7 traditional sectors, he couldn't. He'd have to expand the tower up more and start guiding it, and don't even want to talk about what would happen there. But you can clearly see here that this site is working really well, and they're clustered like they're supposed to. Like they do what they're supposed to do as far as clustering. We can only imagine what the Prism adapters with GPS are going to do. It's going to be quite cool. So are we good on time? Can we keep going here? Just a few more slides?
Please do.
Sure.
Okay. So we want to talk about the outdoor wireless paradigm, right? This is where we see radio systems going in the future. So currently there's three parts to a radio system. You have the radio, you have the pigtail interface, and then you have the antenna, right? This is a traditional radio system on the market. How we want to change this paradigm is by removing the pigtail altogether, right? We remove the pigtail, the radio output connector, and the antenna input connector. And then we remove the waveguide feed from the antenna and actually put it on the PCB. We actually put it on the radio. So we make the radio module itself a waveguide fed device rather than having connectors or an antenna element connected to it, right? So waveguide fed. And then we're able to, again, take the antenna or take the PCB and put a waveguide feed on there and create a TWISTPORT, or what you guys have seen, our SIMPER type radio platform, right? It's our design, our kind of vision of the future on where radios are going, right? So this is practically a zero loss system. So again, it's a one-handed installation, no tools, no taping, kind of what the TWISTPORT adapters do, but with absolute lower loss, right? So we get virtually no loss in this type of future radio system that we're working on, and we see the industry has to go, right? So combining them with waveguide fed symmetrical horn antennas or parabolic dish antennas, you can eliminate coaxial RF connectors and cables and basically have a virtually lossless system. So the performance enhancement of just this type of radio system is, about 3 dB, right? So that's huge as far as link budget goes. It definitely is going to change the way antenna technology, radio technology is in the future, and we foresee other vendors following this path here in the future. So stay tuned. There's a lot of areas, a lot of places for you to find information. Of course, our website, www.rfelements.com. We have an active forum. We'd love to see people join our forum, ask questions, post results, post pictures, give us your feedback. We really want to hear from the customer base. What do you want as a product? A great place for that is rfelab.com. That's our forum site. Again, all the social media sites, YouTube, Facebook, Google+, LinkedIn, and Twitter, great places. If I can say one last thing, I kind of wanted to come back to the industry and the Carmel group I was talking about with WISPA and this kind of marketing paper that they're putting out. There's going to be surveys going out to WISPs out there. I hope that you guys, when you get these, if you get a phone call or you get an email asking you to participate in the survey, please do. This is going to be huge for our industry. It's going to just help you overall, right? In whatever you want to do, whether you're trying to raise funds, get loans, market your company, market your WISP, sell your WISP. I mean, the list goes on as to the benefit of this group. So, again, with that, I'll open it up back to you guys. If we have questions, and we can talk more, or we can wrap it up. It's back to you.
All right, Dennis, were there any questions out there?
Well, I think the last question that we had here, just looking at it, there was a question if they're going to be developing an adapter for connectors, adapter with connectors for connecting a TWISTPORT antenna to a non-supported radio. But I believe that was already covered with those carrier class symmetrical horn antennas. So I think that's perfectly good, if that makes sense. Other than that, I don't see any other questions. I'll give you a little props here. Excellent presentation. A lot of really good information.
Wow. One of the best.
Yeah.
Thank you.
A lot of really good information for even general purpose on design and how you have to design all these. So really looking forward to seeing future products from you, and obviously see you at WISPAPalooza.
Yeah, definitely. Again, thanks for having us on. Thanks for taking the time to help us get the message out there. Again, we're really working to try and make the industry work a little bit better. Noise is key. Spectrum is finite, right? So using the right antenna is really important. Also, our antennas are listed on towercoverage.com. So if you're curious about how these antennas might give you a coverage area, I'll tell you to go to towercoverage.com. Pull up these antennas and map out your deployment and see what kind of coverage you get from them. And again, get involved. If you really like what you're seeing from products, then we definitely want to hear from you as an individual right? So join our questions, email us, get on Facebook. We have a lot of avenues in order for you to contact us. Please do. We want to hear from you. And again, thanks for your time. I know everybody's busy. We went over the hour usually, so I know that this time is precious. And thanks again. I appreciate it.
Excellent.
Well, thank you, Tasos. We appreciate you, and it was well worth going over the hour for sure, I feel.
Awesome.
Yeah.
Awesome.
Before we wrap up here, Stephen, I just want to make sure I remind everybody that next week is actually, again, not saying that I know Tasos' presentation was really good, but next week we do have both Steve Cran and Alex Phillips on the show discussing Title II and what to expect as a broadband provider. So really good stuff. That's going to be Wednesday, July 20th. And then on the 27th, we are going to have Jimmy Carr. He is the WISPA state coordinator, talking about more local products, more local work that you can do with WISPA to help your state level efforts in lobbying efforts, things like that as well. So all really good stuff, all coming up in the next few weeks. So don't forget about that. Also, WISPApalooza. It is Fiber Weekends, the 8th and 9th. It is the 11th through 13th for the actual show. Remember that the next time the fees go up is looks like 9:30. So you still have a little time, but make sure you go ahead and register because get you the lowest price you can. So
you bet.
Steve, with that said, I will let you close up the show.
Well, thanks a lot, guys, for coming in and listening to the show. I think that was one of the best presentations I've seen, and I'm going to go order some of these horn antennas and try them out. So, Dennis, if you'll wrap us up, we will talk to you guys all next week. Thanks a lot, and God bless.
Thanks. Bye, guys.
Bye.
Thank you for listening to ISP Radio. We hope you've gained new insights and additional wisdom in our industry as well as your business. Please remember to visit our show sponsors via the links on ispradio.com. If you're interested in becoming a show sponsor, contact us at sales@ispradio.com. Now go out there and push those packets as fast as you can. Good luck and Godspeed.